All right, so our next example would be if you have fraction patterns. If you have fraction patterns, do not look at it like a fraction. Do not look at it like a fraction. You want to look at it as a different equation on the top and the bottom. This is what you want to look at it as. Different equation on top and bottom. So we're going to look at it as two completely different equations. It's still going to just be 1 sub n, but there's going to be an equation on the top and an equation on the bottom. So let's look at the top. We've got 3, 9, 9, 81, 243. Do you see a pattern? Three, 9, 9, 81, 243. Could you tell me the next number on top? What's making you guys quiet? Nobody knows the answer, or you don't want to say? Don't know the answer? Okay. What up there is throwing you off? The 9, 9, right? Well, that's messing me up too, so let's not even look at it. Ignore that one. 3, 9, something, 81, 243. Is there some sort of pattern that you notice? You guys know about numbers. What do you know about 3 and 9 and 81 and maybe 243? Sydney, what do you know?
30 multiplied by 3.
I'm gonna change your words just slightly. They are all multiples of 3. They are. If I factored 9, it would be 3 times 3. If I factored 81, it would be 3 times 3 times 3 times 3. 3 is 3 to the first. This is 3 to the second. This is 3 to the fourth. Guess what 243 is? Guess. It is 3 to the fifth, right? So what we're doing to get from 3 to 9 or from 81 to 243 is you're multiplying by another 3. That's what we're doing each time. We're multiplying each of these by 3. And if that's the pattern, it should be the pattern for the middle one as well. So if I did multiply by 3, if this is the pattern, I'm just saying, if it's the pattern, if I did multiply by 3, what would the middle number be? Nine times 3 is, Drew, 27. It would be a 27. Is it possible that it was a 27 and it got reduced? Is that possible with fractions, that it could have been a 27 at some point? If this was a 27 and it got reduced, what did it get reduced by? 3. That means the bottom would have also been reduced. If it got reduced, what did the bottom one get reduced by? Has to be the same number, so the bottom number would actually be a 6. For this pattern on top to be true, that bottom number would have to be a 6. So now let's look at the bottom formula. 2, 4, 6, 8, 10. Does that seem like a pattern? What are we doing on the bottom each time? Adding 2. So we should now have enough information to write the top and the bottom patterns. On top, if we were multiplying by the same number each time, that would be a lot like, oh look, I wrote multiplying by same number It is exponential. I even wrote that on this example. Where do I put what we are multiplying by? This one was by 2's. Where did I put the 2 in the answer? Dominic? And I don't see a 2 as the exponent. The base with an exponent. What went in the exponent was the variable. We wrote it is exponential. So this should be, maybe, if I'm doing it right. Kira, what should the top be? N to the 3? I can't hear you. I'm sorry, it's because of my ear.
3 to the n.
Oh, 3 to the n? Let's see if that works. If I plug in 1 for n, do I get out 3? If I plug in 2, do I get out 9? If I plug in 3, do I get out 27? If I plug in 5, do I get out 243? So that is correct. On the bottom, we are adding the same number each time. I know we wrote notes about that. If I add the same number each time. Ethan, did you write down notes about that? There's one right above it where we were adding the same number each time, and it just happened to be the exact same number that we were adding here. The very first question was adding the same number each time. In fact, the very first question was 2, 4, 6, 8, 10, which is what my denominators are. 2, 4, 6, 8, 10. What's the formula? 2n. 2 times n. So that's a regular n. This one up here is 3 to the nth power. Okay, so when you do fractions, you just do a separate formula on top than on the bottom. You do separately. And then you put them together and they're a fraction now. The people that do bad on the tests and quizzes on this stuff, it's because they try to look at the fraction as a whole. All right, last one on this page goes -1, -4, -7, -10, -13. Could you find the next number? Ella, could you find the next number? -16 is correct, so you must know the pattern. What's happening each time? And we're doing it over and over again, subtracting 3 each time. Tells me right away a sub n has to start with what? Alex. It's got to start with -3n. It has to start with -3n. When it goes down or goes up by the same amount each time, it's linear. So we put it multiplying by n. Guess what? If I were to graph this, this would be the slope. That would be the slope because our x's or our n's are just going up by 1 each time. And then our y's are going down by 3. That would be the slope. So -3n. Is it only -3n, or do I need to put something else in there? Let's see. If I do a sub 1 and I do -3 times 1, I should get the answer of -1. Do I?
Yes. I didn't say that. It's +2.
Who said yes? Blame it. Oh, that was Zell. That was Zell. Okay. It's +2?
Yeah.
Are you sure, though? Let me try a different one. Let's do the fifth one. A sub 5. If I do -3 times 5, I have to get out -13. And you're telling me add 2. Does that work?
Yeah, I know.
I heard both answers.
Yeah, it should.
Oh, it does work. If it works for all of them, you have the right formula. Some people, I believe, in this class said, can I go and find the 0 term? That's also a good idea. I mean, there isn't a zero term, but you know enough about math that you could find the zero term. What take away 3 ends up being -1? What would be the zero term? If I take away 3 from it, I get -1. So to go the other way, I would add 3. What is that? 2 should be the zero term. So if I do a sub 0, I get -3 times 0 plus 2. So that number would match there, the zero term. Okay, but when you do have series like we do here, 0 isn't a term. Well, we can find it, but it's not a term. So that is the end of these notes. You need the go to which one?
The one that
You're good? So open up those notes from Monday if you don't have them already. It just has some vocabulary on it that we kind of talked about, but you didn't have a copy of it because I hadn't posted these yet. And we have to add on factorial today. So a sequence is a function whose domain, the input, the numbers you put in, is the set of positive integers. That's why 0 is not a term. There is not a zero term. It starts at 1 because of the definition that a sequence is a function that starts with the first term and is positive, like a sub 1, a sub 2. Here it's showing you that if you plug in 1, f of 1, that gives you the value of the first term, a sub 1. And you guys were asking me about what I was saying, so I had written it on the board. But each time I say this, I am saying a, and then I'm saying sub n, or a sub 1, or a sub 4. I'm just using the word sub. That stands for, it's down here somewhere, subscript. That's what sub is, subscript. I hope you can read this and actually know the answer without me having to read you the definition. A finite sequence is a sequence that has an ending. It doesn't go on forever. And an infinite sequence goes on forever. Okay? Finite stops, infinite goes on forever. Each member of the sequence is called a term. The subscript is used to denote the different terms. We did this on the other set of notes that you downloaded with a partner. We've already done find the first 5 terms. I'm not going to do that one. Okay? We have already done find the first 5 terms. I'm not going to do this one either. We've already done those. I'm just going to be like, bye. Okay. What I'm going to do instead is talk about factorial, because there's not really a space on here that talks about the definition of a factorial, so I'm just going to add in what factorials are. And this is totally in my own words, to look it up to see what the actual math definition is. Factorial. Factorial, like an exclamation point, but we call it factorial. You don't say exclamation point. You say factorial. And what this means to do is take the number with the factorial, take the given number, and multiply it by 1 less of itself, and multiply by 2 less of itself, then 3 less, etc., until you multiply by 1. So take the given number, multiply it by 1 less of itself, then multiply it by 2 less than itself, then multiply by 3 less than itself, and you keep taking 1 less until you get to multiply by the number 1. Then you can stop. So some examples of factorials could be 2 factorial. So I would take the number 2 and I would multiply it by 1 less than 2, which is 1. And 2 times 1 is 2. So the answer for 2 factorial is 2. 3 factorial. I would take the number 3 and I would multiply it by 1 less than 3, which is 2. And then I'm going to multiply by 2 less than 3, which is 1. And if I have 1, then I stop. 3 times 2 times 1 is 6. 4 factorial is going to be 4 times 3 times 2 times 1, which is what number? 3 times 2 times 1 is 6, times 4 is 24. So what I'm doing each time, I didn't write 1 factorial down. I should write 1 factorial. 1 factorial is 1. So to go from 1 to 2 factorial, we multiply by 2. Then when I go to 3 factorial, we take the 2 factorial and we multiply by 3. Then we take the 3 factorial and we multiply by 4. So you're like multiplying by 1 higher each time. So our example to start says find a sub 5 for this a sub n. What does find a sub 5 mean we do? We're going to find the 5th term. How do I do that? What do we mean? What does that mean to do? Plug in 5. So we're going to plug in 5 for all n's. So I will have 5 factorial over 2 times 5. So what's 5 factorial? 5 times 4 times 3 times 2 times 1. Okay, so you could multiply that out, but I'm actually not going to, because after I multiply it out and I multiply the bottom, I am going to see if it simplifies. So I like to see if it simplifies before I waste my time and multiply this out. Are there any factors on top, numbers being multiplied, factors on top that would cancel with factors on the bottom? Like a 2 and a 5 cancel. So when I actually multiply, I will get 12. Prior to that, we had 120 over 10, I think. Is that what it was? If you multiplied it out. Okay? Simplify the factorial expression. So 3 factorial is 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times 4 times 3. It's 2 times 1. Before I multiply it, are there any factors of this factorial that we could cancel out? 3, 2, 1. So I'm actually canceling out 3 factorial from both of them, right? So we have left 7, 6, 5, 4. Multiply those. 42 times 20, 840. What's my answer? What's my answer? Was that Gavin? Was it Gavin? Okay. Gavin, say it again. 1 over 840. Yes. Make sure you don't write 840. Because on top, we canceled everything out, but there still is a 1 there that stays there and holds that numerator place. So when we're canceling values of 1. 3 over 3 is 1. 2 over 2 is 1. 1 over 1 is 1. So this is still a 1 on top. Okay? Next one. 100 factorial. 100 times 99 times 98 times 97. What, Kia? Times 96.
No way. Please subtract 98 and 28.
Do I need to keep writing them?
No.
No. Because why?
You can just do like 99 times and then over 1. Right?
Why?
And to cancel out.
What? I didn't hear the last thing you said. Sorry.
They cancel out.
Oh, they cancel out. Okay. So what is 98 times 97 times 96 all the way down to 1? What is this right here? This is 98 factorial, right? So if we have large numbers or small numbers, if we have numbers that you don't want to write all the way out, because I don't, what you can do is you can expand out the bigger number. Expand the bigger number. Until it matches the smaller factorial. Then cancel those factorials. So what Kia is saying to do is do 100 times 99 times 8 factorial, which takes care of numbers. On the bottom, 98 factorial stays 98 factorial because I don't want them out, but they all. So we get 100 times 99, which is 9,900. I took the time to write that out because the next example does not have numbers. So in order to reduce this, we have to decide which of these is bigger, and we have to expand out the one that's bigger. So what's bigger, n minus 2 or n? Why is n bigger and not n subtract 2? Because subtracting makes it smaller, right? Okay. So we're going to expand the bigger one until it matches n minus 2. So I'm going to start with n. And I'm going to multiply that by, what's the rule for factorials? What's the next number? What's the next number? It's n minus 1 for this, but why? What's like the rules say to do? 1 less than the number itself. So we subtract 1. That does not match yet. So then the rule says factorial number, take away 2. And minus 2 would be our next one. Do they match? So I make this the factorial. That takes care of all the rest of them. And then we can cancel those. So what do we get after we simplify? Kennedy. You can either get 1 over n times n minus 1, or if you multiply it out, 1 over n squared minus n. Either of those would be fine. Okay. So this next one, expand the bigger one. Which one's bigger? 5n plus 1 or 5n? Plus 1 is the bigger one, right? So if we're going to expand 5n plus 1, then I'm going to have 5n plus 1 first. My next one is going to be 1 less than 5n plus 1. So 5n plus 1 minus 1, which is what, though? Hold on, that's just 5n. Okay. And once I wrote 5n down, then I realized that matches, and it's time to cancel. So 5n plus 1 is the answer. So that's simplifying factorials. The very last section is what you were working on with your partners. It was like the second page of what you were working on with your partners. I didn't tell you much about it. I told you to figure it out. And then we kind of, some of you had questions and I walked around. The way that it's written here is called recursively writing a sequence. It's a recursive form of the formula. For these, you have to know a term to get another term. You can't just jump and say, hey, what's a sub 5 and plug in 5. You would need a sub 4, a sub 3, you would need all those terms to get to a sub 5 if you were doing that. So we were doing this on Thursday, and I said just plug in 1 or plug in 2 and figure them out. So I look at this one, and I already know a sub 1 is 15. So that is my first term. What would be something that I could try to find a sub 2? What do you think, Sydney?
You could do like a sub 1 plus 1, which is a sub 2 equals a sub 1, which is 15 plus 3.
So you are saying, let's try plugging in 1. That's what you're saying to me for the case, for K. So if I plug in 1, I'm going to have a sub 1 plus 1 equals a sub 1 plus 3. And I know a sub 1 plus 1 is a sub 2. And I know a sub 1 has a value of 15 because that was given to me, plus 3. So by plugging in 1, we're actually finding the second term, which is 18. So what could we do to find the third term? Isaac, what can we do to find the third term? What did I just plug in to find the second term? I plugged in 1. So to find the third term, I can plug in 3. I'm going to get a 3 plus 1 equals a sub 3 plus 3. So I'm going to get a sub 4 equals a sub 3 plus 3, but I don't know the third term. So what should I plug in? I should plug in a 2. So I showed you plugging in the wrong thing to let you know, like, if you plug in any other number other than the one you're supposed to plug in, you're going to have to plug something else. Like you'll know you can't do it. So if I plug in 2 instead, I'll get a sub 2 plus 1 which is a sub 3. Have a good lunch. We'll finish after lunch. Okay, so again, 3 ends up being 21 because we do a sub 2 plus 3. I just put it in the wrong line though. There we go. And then to find a sub 4, we do a sub 3 plus 3, so I'm doing 21 plus 3, which is 24. What pattern do you see? What pattern? You add the 3 each time. We're adding 3, right? So if I asked you to now find the nth term, that would be like find a sub n. Now that you have 4 or 5 terms to choose from, I could find more. I think you have to find the 5th term, 27. We have 5 terms to choose from. How would we find a sub n? If I'm adding 3n, or sorry, if I'm adding 3 each time, it's going to be 3n, but is it just 3n? How are you getting plus 12? Oh, okay. So really it would be if I was doing the 0 term, which really isn't a thing, but you could find the 0 term to help you know what you'd add on in the end. Right. Okay? I'm not going to do the last one. It's similar to it. I'm not going to do it. You guys have the rest of the time to work on your assignment, and you should have already done a lot of that assignment. There were just certain questions that I knew you could not do until we finished our notes. So I would like to answer any questions on the stuff you have done so far, and then you guys take the time to finish the stuff you haven't finished yet. It is on Canvas if you've forgotten. And the book link, it was on last Wednesday.